of many small, like maybe solar, wind, fuel cell, biogas, or small hydel. So it may be a combination of various types of generating sources. So whenever whichever is available, so it is very flexible and efficient. So it provides you the reliability of the power. So whenever the grid power is not there, it can supply the power to the local loads. So in that sense, otherwise, in the absence of the grid power, there will be no power. So this is an additional source of power. It is connected to both local generating units and the utility grid, thus preventing power outage. What I just said. So future microgrids will allow high renewable penetration and become building block for the smart grid with the help of advanced communication and information technology, right? So as I told you, it's a building block of the smart grid. Means if it is right penetrating high renewable generation, right? So we will. Our aim is to introduce as much as the renewable energy to the microgrid, so it can become support for the smart grid. Excess power can be sold to the utility grid, right? So if your generation is more than the load demand, so the extra power can be sold to the utility grid. So this is an added advantage. Size of microgrid may range from housing state to municipal region, right? So at that distribution level, you can say it is connected. So now we can define the microgrid as, however, there is no clear definition of microgrid, and the concept varies different countries and region, right? So they define according to their own country or own region or own situation. So based on the European technology platform of smart grid, a microgrid is a platform that facilitates the integration of distributed generation, energy storage system, that is DG and ESS, and load to ensure that the power grid can supply sustainable, price competitive, and reliable electricity. So that is what they defined it, that is including its use also. That is the main purpose of this microgrid. So this is a definition, one of the definition, although the definition may change country to country and depending on their situation and their requirement. So, but one of the definition which can be generalized like this. Now, this is the microgrid structure. It may be connected to the main grid, right? There is a switch there. So, if we want, we can connect it to grid also. And if we want, we can disconnect and we can work in the islanded mode. So, there are two modes possible, grid connected mode, and when it is not connected, so it is known as islanded mode. Now, you see, there are two types of load is there. When grid it is connected to grid, the power can be supplied from the grid also and from the DGs also. So when this power generation through DGs is less than the load, so the combination of the two will work, right? So when grid failure is there, or we have disconnected this from the main grid, suppose the price is very high, we would not like to take the power from the main grid, we will disconnect and we can supply the load through our own generation, right? So these DGs may be a wind type or PV type, fuel cell, micro turbine, or some other type of small sources of energy may be there. And these are the storage device. You can say you can store the energy in the form of battery. You can store the form in the form of capacitor or flywheel or compressed air. So whenever energy is more than the load and grid is not connected, so you can store the energy in these forms, and that can be supplied to the load when DG power is not available. So these are the storage, different form of the storing the energy when energy is in surplus. So when energy is more than required, then there is two possibility. We can use them to store in battery or some other type of storage, or we can supply it to the main grid. So when these are already charged and load is also less, in that case we can sell the energy to the main grid. So you can adopt any of the strategy whichever is useful for you. Now, many types of DG units are more sustainable. As I told you, if we depend only on wind and PV, there may be a problem, right? These are intermittent in nature, means they depend on the weather type or the season wise, they have different generation, and forecasting is difficult for them, right? So we cannot rely only on wind and PV. So it is suggested that the microgrid should be a combination of various types of generating units, right? Many types of generating units if there. So when PV is not available, you can get power from the wind, and when wind is also not available, then you will be right dependent on the grid only. So then, if you have other type of source also, you can deliver power through that source also. In such cases, DES can play essential role. This is storage, improving the stability and strengthening the reliability and ensuring the security. Right. If you have a storage device also along with these DGs, so when surplus power is there, like in daytime, generation through PV is good. In night, it may be through wind, right, or some other sources. So when load is less, the generation is more, you can store that energy, and that can be used when demand is more and generation is less, right? So along with the storage device, right, this is distributed energy storage, you can say. So we can improve the stability and we can improve the reliability and we can ensure the security also. And not only can DES unit be used for smoothing and fluctuation from the output to DG, but they can also contribute to the stable operation of the microgrid, right? So smooth function is possible through DES, but they also contribute to the stable operation of the microgrid also. Right? Stability may get disturbed. Suppose you are having only PV or wind, and suddenly the wind is stopped and sun is also not there due to clouds. So sudden load will increase on the conventional or rotating synchronous generator. So that may have some disturbance or no, stability may be disturbed due to sudden outage of the generation through DGs. Load will suddenly increase on the conventional generators, right? So that can create a stability problem. But if you have storage, so whenever generation is not there, we can supply the power through storage also. So that will help in stable operation of the microgrid also. So advances in the material science and power electronics technology have facilitated the effective employment of new DES facility, right? So different types of materials are available. Batteries improving, power electronics technologies are also new components we are new designing. So that is helping to make all these things possible. Now, this is a typical hybrid microgrid diagram. You can see it may be AC type, it may be DC type, right? And they can be interconnected. So this is AC bus, and which is connected to a utility, means conventional, means the grid is connected to this. And all these are means AC equipment. You can say storage is also there. The flywheel, compressed air, these are all storage. Now, diesel generator you can also supply to this. So one of the source. Wind can also supply power, the wind generation. So it is generated in AC form, right? So AC to AC converter may be there. So that means for means at means generation may be at different frequency. You want some other frequency. So AC to AC conversion at different frequency and different voltage level is possible. This converter will convert this AC of different frequency, because wind is the speed is varying, the frequency may be different. So you want constant frequency as output. So this is micro turbine, means a small idle is there. So that is also rotating part. So AC is being generated, and thus AC can be converted to the desired form of the AC, the desired voltage and desired frequency output you can get. So AC can also be converted to AC of desired frequency. So frequency can be changed, voltage level can be changed by this converter. So AC load means it can be supplied to the AC load also. So this is AC bus. Now sometimes we have some DC components also, like heating equipments or something. Like PB is generating power in DC. So DC converter means here also DC converter means DC of different voltage level at DC at different voltage level can be generated, or you can smoothen the DC because there may be fluctuations, so you can smoothen that. So this converter's job is, this may be a chopper or this may be DC to DC converter, which can change the voltage level of DC also. And this is a DC bus, means all DC type of load can be connected to this DC bus. So no need to convert DC to AC sometimes. So various types of loads are there which can operate on DC also. They can directly be supplied through DC, but this extra DC can be converted to AC, and this can be connected to grid also. And DC to AC conversion possible here, which can be connected to the AC bus also. Right. So all these are DC components we connected here. So any doubt? Okay. So microgrid components, you can say, oh, different diagram. You can say, so the components mainly distributed energy resources. The resources may be of various types. It may be more than that. Different types of generation for microgrid are available. Load is also part of the microgrid. Immediate storage, controller, and point of common coupling. Right. So these are the basic components of the microgrid. So microgrid, you can say. This is another diagram showing the same thing in a different way. Okay. Now, what are the microgrid operating modes? You can say the one of the mode is a grid connected mode, means in which the microgrid is connected to the grid. This is point of common coupling through which it is connected to the grid. Conventional grid, utility grid. So utility grid is active. In this case, static switch is closed. This switch here, if it is closed, that means it is connected to the grid. All feeders are being supplied by the utility grid. Now here we can see grid can supply to all possible feeder A, B, C, and D also. Local generation is also there. So if local generation is not sufficient, so extra power can be taken from the main grid. And this feeder is not having any DG support. So, but it is supplied from the main grid. So in this grid connected mode, all loads are supplied. So if power is not sufficient from the microgrid, so it can be supplied, additional power can be supplied from the grid in this case. Now, islanded mode means when grid power is not there, and there is power failure or due to any reason the switch is closed, so it is disconnected from the grid. Now, as you know, in this particular example, feeder D is not having any local generation, so when grid is closed, this will not be supplied power. So, and these generators can supply it to their own loads. So the power matching is important. So when grid is not there, whatever is a generation available, if load is more than that, so you have to cut some load. So that power balance control should be there in the microgrid. That is a challenge in case of islanding mode, right? So here you can see feeder grid is dead, means it is disconnected. Feeder ABC are being supplied by the micro source, means microgrid is supplying power to that. Static switch is open, means it is open, so grid is disconnected, right? So we can do it when grid price is very high, so we don't want to take power from the grid, and our generation is sufficient enough to supply the local loads. We can disconnect the grid, or whenever there is a fault on the grid, means that power is not available. In that case, we are forced to use the local generation. So in both the cases, the islanded mode will work. So we can disconnect it from the grid also. This is one of the mode. What is the need of microgrid? Microgrid could be an answer to our energy crisis. Now, energy crisis is there in India. It is more, means generation is less than what demand is there, and demand is continuously increasing. So you can say that affordability is increasing, so everybody is increasing their load. They are buying larger fridge, they are buying ACs, they are buying washing machine. Earlier, we're not using all this because the income was also less. So when affordability is increasing, the people are going for more comfort. More comfort means everything needs some energy to operate that. So energy crisis is coming up. So generation we cannot increase. The conventional generator means if you talk about the thermal generation, it is being discouraged means because of the environmental reasons. It emits a lot of carbon, CO2 emission is there. So that is not advisable. So we have to go for some renewables. But renewable of large scale is also not possible for installing solar plant. A lot of space is required. So we can go for the smaller microgrids. So this is one of the option. In this case, the power is locally supplied. So some load is reduced. Means the conventional generating station for that the load will be reduced. The remaining load only will be visible to the conventional generating plant. The transmission loss gets reduced because that power is being locally supplied. It is not flowing through the transmission line, long transmission line from generating station to the load centers. Any doubt? Anybody? Some of mics are on. So the microgrid results in sustainable saving and cut emission without major changes to the lifestyle, right? So we don't have to change. Means आपको AC off नहीं करना है कि बिल बचाने के लिए because आपका locally supplied है. You have got your own solar plant. So and that is not generating. And so we are saving some money and we are not. And indirectly, the emission is reduced without any change in the lifestyle. So we are using all the loads because we are not dependent on the grid also. We have our own generation. So each house may have their own means generating plants, solar plants. Or there may be a microgrid which is serving to a group of houses, right? So that is indirectly means supplying you power at cheaper price also, and right, indirectly you are saving CO2 emission because otherwise that load would have been supplied from the thermal plant and thermal plant will be emitting more carbon. So you are saving some carbon emission. So provide high quality and reliable energy supply to the critical load, right? So critical load means otherwise if power is not, there will be a power cut. So if you have microgrid, so that critical load can be supplied. So whenever there is power cut and your generation is not sufficient, so at least the critical loads can be supplied, right? So that is the meaning of this. Benefits of the microgrid. In this and other way, we can say microgrid provides an efficient way of integrating small-scale DERs in proximity of load into low voltage distribution network. So they are normally in the low voltage distribution level. We don't connect it to the transmission line. It is at the distribution level. Microgrids can supply highly reliable power to the wide range of customers, both residential and commercial. For example, school is a load where you can connect. Can have its own microgrid, or hospitals can have its own microgrid. So these are critical loads also. Like hospital, the power should be 24 hours available. If there is a power cut, if they are having their own microgrid, this critical load can be supplied. Otherwise, they were having their generators. No? So that is not desirable because that emits again a lot of CO2. So warehouses, similarly shopping center, university campus, military installation, data centers. So all these are big units and they can have their own microgrid, right? Like small township, they can have their own microgrid like this. So it can supply to a group of people, group of houses or large units like school, hospitals. So it is also useful for remote places having no or limited access to the utility. As I told you, there is a village where there is no electricity has reached till now. So they can have their own because sun is reaching everywhere. wind is reaching everywhere. And if they have a small water unit, so they can have a small micro hydel plant also. So that way means we can supply to the remote areas where the power is not reaching till now. So, but we can install microgrid there. So this is an advantage of the microgrid. Further, it is beneficial to the customer facing large power outage. सपोज आपका पावर तो है लेकिन वो लोड बहुत ज़्यादा है और सप्लाई उतनी नहीं है तो आपका पावर कट बहुत ज़्यादा होगा या मेंटेनेंस प्रॉपर नहीं है फॉल्ट्स आर मोर in that particular area if microgrid is there that can give you some reliability of power supply. So in case of power outage microgrid can supply power to that area. Microgrid technology can also be used in the area of facing high stress congestion in their transmission distribution system. Similar means these two can be combined. Integration of renewable energy resources help curb the dependency on fossil fuels, right? So the coal is continuously reducing, but that is also means burning coal is also generating carbon emission or CO2 emission is there. So that can be indirectly reduced, significantly reducing the carbon emission and pollution, and thus promotes energy sustainability also. So normally microgrid will be using renewable energy only. So indirectly we are saving some fossil fuels and we are reducing the carbon emission also. With proper control, microgrid increase the electrical reliability by decreasing the outage occurrence as well as their duration. So ये आपका वही same thing is written in different way. Utilities see microgrid as controllable load which can contribute to the peak shaping during the times of peak demand and by reducing their own consumption via shading the non-critical load and delivering more power to the main grid, right? So peak load can be shaped. So that means microgrid can help generating some power so that otherwise the load was more. So that peak load is reduced as seen by the utility. So indirectly means when load is peak, the energy prices are also normally high at time because then utility has to generate more power. It has to turn on all the units at that time. So if we have microgrids connected, so that peak demand can be reduced. That will be saving some money also for the utility. Also, it is beneficial as per the stability point of view. Otherwise, there would be a load cut if microgrid is not there. So microgrid can lower the overall distribution system losses also. Losses are also reduced as I told you, because if microgrid is in the absence of the microgrid, that same power would have been flowing from the generating station to through the transmission line and distribution system to your home. So that will be creating a lot of I square R losses. So losses, these transmission losses are reduced, right? So if you are having microgrid that is supplying the load locally. Now, integration of microgrid to the distribution network. Conventional DGs are usually directly interconnected to the distribution network at medium or high voltage level. However, generators in microgrid, e.g. PV, wind turbine, fuel cell have relatively small installed capacity up to few hundred kilowatts only. So smaller units. These generators should be connected to the distribution network at low voltage level. In conventional power system, loads are passive and power only flows from distribution substation to the consumer. One way that we discussed in the smart grid also same thing, but not in the opposite way. But power can flow in both the direction between microgrid and the main grid, right? So it is now two-way. So accordingly, changes is to be done in the grid or distribution system also. Now, operation strategy in microgrid. The load control scheme in microgrid can either run non-automated or automated load. Right? In non-automated mode, the customers can obtain the electricity price and choose whether to switch on or off the load via remote control, right? So this is non-automated, means आप consumer manually वो करेगा. He can decide what to do. Means आपको electricity price मिल जाएगा. So tariff will be available to you. कि during this hour the price of electricity is less, and during these hours the price is very high. So when price is very high, you would like to cut some load, right? So you will switch on or off load according to, means manually. It is not automated, right? So when it is in automation mode, so that can be controlled by a pre-program or receiving control signals. Means computers may be used to at your home, and they are connected to your load, and program is there. So continuously it is reading the price from the utility through internet. What is the price right now? And accordingly it will take decision. When price is high, the load is to be cut. So load which are not critical and which can be shifted to some other time, so they will, like washing machine. I mean, so everything is connected. Switch on off is control is with the computer. So it can reschedule the washing machine or reschedule the program of dishwasher, or your watering system in the garden. So all that can be rescheduled. So they are not time dependent. You can do it whenever the price is less. You can do it in that time. Or the charging of the battery. All these loads can be shifted when price is low. So otherwise, when price is high, normally demand is more also. So you have shifted. That means we'll see it in the demand response program. So this is a part of demand response program. So objectives of the microgrid operation. So objective of the microgrid operation depends on the stakeholders' interest. These stakeholders could be कौन होंगे structure microgrid operators. It may be जिनका microgrid है. So the owners of the microgrid are the stakeholders. So accordingly आपका objective different हो सकते हैं. Distribution generator owners may have, if they are the owner, they can have their own program. So the objective may change depending on who is the stakeholder, right? So it may be distributed generator operators. Consumers may also be the stakeholders. They have their own PV station, right? So to maximize the economic profit, the objective is to minimize the total microgrid cost, right? So one of the objective may be this, right? तो आप इस तरह से ऑपरेट करेंगे कि हमारा जो है cost of microgrid should be less, taking into consideration the impact of the microgrid on the main power grid and the environment. So whatever is the, if you write the program and objective function is like that, you have to reduce the operating cost of the microgrid, so you can operate in accordingly grid. So when grid price is less, you would like to purchase the power from the grid. When grid price is high, you would like to take the local power from the microgrid. So in that way, means the program can run, and control features are there which are controlling on and off, when switch is to be on, when you have to connect to the grid, when you don't have to connect to the grid. So looking into all possibilities, it will operate in such a way that the cost of the microgrid, operating cost of the microgrid will reduce. And right, it can be to maximize our technical profit. And the objective is to minimize. The objective is different now. Suppose you want to maximize the technical profit. So in that case, the objective is to minimize the total power losses, voltage fluctuation, and this option has been adopted by a majority of the system operators, right? So if you change this objective, the strategy will change. So depending on your requirement and who is the stakeholder, they can have their own objectives, and depending on the objective, program will run, and it will operate the microgrid accordingly. So if you read different papers in the literature, so if you see different papers are there, and they are considering who is the stakeholder, according to they have written the program, and they have shown the result. Whatever is their objective, that is maximized in that case, right? So when you are trying to maximize the technical profit, economical profit may not be there. So when you want to maximize economical profit, technical profit may not be there. Or when you can use hybrid of this also, right? Both you want to means compromising solution you want. So you can combine both are more objectives in your program. So to maximize environmental benefit, this may be the objective, right? So you want to reduce the carbon emissions. So as much as possible, you would be dependent on the microgrid, right? The final goal is to combine all these above economic, technical, and environmental factors to achieve maximum comprehensive benefit. So you can combine all these objectives to make a multi-objective column, and a compromising solution will be achieved, right? So it depends. What do you want, and who is the owner? So what he wants, accordingly, he will write his product. Now, microgrid market model, right? So it is like when what means suppose you are selling the energy, you would decide what should be the price of your energy. So you will bid that price. So if you are a big microgrid owner, so you can, utility will ask you the price of your electricity, and so during which hour when demand is more, at that time you will give more price, and when demand is less, you will give less price. So that is when utility requires, because there is a demand is more, it's a peak load time. So they would like to purchase the electricity from the microgrid also. So you can bid your own price also, and utilities also bidding their own price. So it is also a market. So this economics is coming in this, not engineering. So this is also one of the advantage, or you can say one of the part of the microgrid. So you have to decide what should be the best price of electricity for which time. So you will decide your own price. So that is the purpose of this. Different situation. We will discuss the demand response also. We will see in that. Now, microgrid control, coming to the microgrid, this is most important feature of the distinguished. Yeah, that is the only thing. The control is possible. This is the only thing which is distinguishes the microgrid from the conventional distribution system as its controllability, right? So this controllability distinguishes the microgrid from the conventional distribution system. So now if distribution system is having microgrids, so the controllability is there. So it is different from the conventional distribution system. So the purpose of which to make a microgrid behave as a controllable, coordinated module when connected to upstream network, means connected to grid. The function of microgrid control can be divided into three parts. Upstream network interface decides whether the microgrid is able to operate in grid connected mode or in islanded mode, right? So this interface decides when you have to connect, when you have to don't have to connect. Microgrid control means includes voltage and frequency regulation, real and reactive power control, load forecasting, and scheduling of microgrid monitoring, protection, and black start, right? So this is microgrid control means when they are in islanded mode within the microgrid, this is the control, right? So this upstream network means just a switch when you want to connect to the grid, when you don't want to connect, when that switch is to be on, when that switch is to be off. Within microgrid, these are the controls required. Now, local control and protection level encompasses the primary voltage and frequency regulation of primary and real reactive power control, both each local generation and energy storage unit. Right. So this is also within the microgrid only. Here it may be means when it is grid connected. So what should be the microcontrol within? And this is when totally isolated mode. Now, centralized control versus decentralized control. Centralized mode, the microgrid center controller, that is MGCC, plays the most important role in optimizing the microgrid, right? So it is a centralized microgrid. Suppose आपका पूरा city का एक complete microgrid है, means it may be a combination of many microgrids. So centralized facility is there, which is controlling all the microgrids. So it is looking the complete city. Suppose we are going for the smart city, means it may be having a combination of many microgrids. So that is known as microgrid park. So when more than one microgrids are there, so there should be a centralized control for that, which is controlling all other microgrids. And decentralized control means that microgrid is independent of each. They are looking their own local demand and they are concise to that small locality. Or suppose the microgrid is for that particular hospital only, so they are managing their own. So they are decentralized. Suppose, although there are means each school is having their own microgrid, hospital is also having their microgrid. Your house is also having you are small locality, numbers of 100 flats are there. They are that small township is also having their own microgrid. But if centralized facility is not there, so you are running your microgrid independently, looking after your own profit. But when they are interconnected to each other, that then there is a central facility should be there which is controlling all the microgrid. So that is a difference. So microgrid control methods, right? So these are three methods. You can say PV control, VYF control, and droop control, right? So what are these control? Just have a brief difference. So what is PQ control? And main objective of PQ control is to keep the micro source active power and reactive power constant when the frequency and voltage deviation stay within the prescribed limit. So when frequency and voltage are changing, you want to keep your P and Q constant because that is to be supplied. आपको अपने load जितना P चाहिए जितना Q चाहिए वो constant होना चाहिए. So when your frequency and voltage is changing, you are keeping your PQ output constant of that microgrid. So that is the main. So in PQ control, the active and reactive power are firstly decoupled in order to achieve the independent control. The active power controller aims to maintain the active power output, right, constant at the given reference value within the permissible frequency range. So active power is connected to frequency basically, and reactive power is connected to the voltage, right? ये तो आपने पढ़ा ही होगा. तो ये conventional system में भी होता है, means whenever active power demand is increasing, right? So speed of the generator is reduced, so that will change the frequency of the generating station. When reactive power demand increases, that means you have to control the field system of the generator side, means you're right. So that means that is affecting the voltage of the system. So active power is related to frequency and reactive power related to voltage, right? So those have to decompose. So by changing the frequency, you can control the active power. By changing the voltage, you can control the reactive power. However, this peaky control method cannot maintain the frequency and voltage constant. So an extra distributed generator is needed to regulate the voltage and frequency of the microgrid within the acceptable range. So it is changing, means we have to control P and Q constant, your F and Q V is changing, so you have to put an extra distributed generator which is controlling this actually. So that is all to be kept constant. So if microgrid operates in a grid connected mode, the main power grid is responsible for maintaining the voltage and frequency of the microgrid, right? So this is it. When it is connected to grid, the main grid will be controlling the voltage and frequency. When it is not connected, so you should have an extra generator in your own system in your microgrid which is controlling this, right? So this is it. This is V by F control. And the main objective of VY control is to maintain the system frequency and voltage magnitude constant regardless of active and reactive power. It's just opposite to that. We want to keep V and F constant. The frequency controller, normally it is used in islanded mode, right? So when it is in islanded mode, because VF control is not, otherwise when it is in grid control, the grid is maintaining that voltage and frequency. So when it is connected to grid, so that is not a problem. But when it is in the islanded mode, VF control is to be done by the microgrid itself. So in that case, in islanded mode, VF control will be used. The frequency controller adjusts the active power output to maintain the frequency at a given reference value, right? जिसमें active power control करेंगे frequency constant होगी, just opposite to that actually. Now droop control means, and this also active power control is there. This is the equation given, right? This is change in power, P2 and P1, right? In this example, you can see this is P1, the corresponding frequency is F1, this is P2, the corresponding frequency is F2. So relation between active power and output frequency, right? So in the microgrid, the local load keeps changing all the time. So P is changing. So generators will change their output based on the frequency deviation. So the relationship between the active power output and frequency can be described in this equation. So as P is changing, you will control it by the changing the frequency. So desired output can be achieved, right? And another control of group control, within group control, voltage control is also there. So you can see that is by controlling the Q. If you, for this corresponding Q, voltage is this. For some other Q, voltage may be different, right? So by, in the same way, by controlling the Q, you can control the voltage. That is voltage control. So this is known as group control. Master and slave control, right? So when microgrid operates in islanded mode, either the DG or ESS of the master unit will take VF control role to provide a voltage and frequency reference for other DGs and ESS within the microgrid, right? So when it is in the islanded mode, it becomes master. Meanwhile, other DGs and PQ control mode, the controller with VF control method is named as the master controller, while the other controllers are the slave controller. So one of the DG will become the master, other will be the slave. So master will be having this VF control, that we have seen here also, in this, right? So when islanded mode, one of the means it has to be controlled by locally. So one of the DG will become the master. So that is master slave control. In this diagram, you can see this is master controller and these are slave controllers, right? So this diagram is showing. This will be responsible of controlling the V and F. So it will be in the VF control mode, other will be maybe in PQ mode. Okay. These are PQ controller, this is PQ controller, this is VF controller. So it is in the islanded mode means when this is connected. So one of the microcontroller will act in this case. So this will act as a grid in this case. Otherwise, when it is connected to grid, grid will take care of your voltage and frequency, right? Another control is peer-to-peer control. Peer-to-peer control of an islanded microgrid, all the DGs and ESS unit are equal with no master-slave relationship involved. This is another model using the group control method designated. DGs and ESS unit are capable of adjusting their power output based on the locally measured voltage and frequency. So all are independent and all are equal and they are doing their own control actually. So any large change in the load can be actively shared among the selected DGs and ESS unit based on the individual group coefficients. So that is defined which DG will share what percentage of the load and accordingly it will. So in the similar manner to the frequency group control, the traditional synchronous generator, this peer-to-peer control belongs to error frequency regulation in that it allows some frequency and voltage deviation from the desired value. Compared with the master slave control, peer-to-peer control enables each DG and ESS to automatically participate in the power output allocation with which facilitates the plug and play function of DG, right? So this is that model. So all these DGs are independent. There is no master slave concept. Okay. So group controller 1, group controller 2, group controller 3, and they are controlling. So, right? So all are independently controlling that. One is the hierarchy model, right? In hierarchical model controller, that it is different. इसमें एक main controller होगा, central controller होगा, and all are independent. Other controllers, dependent control. So this is another model of control. So many control techniques. So this is in one particular reference I have used, and if different papers, different control strategy may be defined. So you can have your own control strategy also. What you will do for your microgrid. So you can write paper accordingly, right? So these are some examples. Some control strategies are shown in these the three control strategies. It is not hard and fast that you have to use this type of. These are some major control standard control strategies. You can have minor changes in your own microgrid. So when you are writing paper, if you think this is not correct, so you can suggest some new strategy also. So by reading all this, if you can have your own idea, you can implement your own idea also, and a new strategy will be defined. So you can do some minor changes depending on the your situation and your microgrid. So these are some standard controls are there. Now, as I told you, interconnected microgrid, there are more than one microgrid, so they can be interconnected. So then it is known as power park. So practical size of microgrid is limited to few megawatt MVA, right? For larger road, it is desired to interconnect many microgrids to form a larger microgrid network called पावर पार्क. आपने कई सारे माइक्रोग्रिड कनेक्ट कर दिए, तो हो सकता है आपके पास उस समय जनरेशन अवेलेबल नहीं है, दूसरे ग्रिड में अवेलेबल है, वहाँ लोड कम है, आपका लोड ज़्यादा है, तो दैट कैन बी शेयर्ड. So there will be an added advantage. Other microgrids are also there, and right, so you can take power from that also, and you can supply power to that depending on the load requirement. Suppose आपके पास जनरेशन ज़्यादा है, लोड कम है, उधर लोड कम है, जनरेशन ज़्यादा है, so you can share that. So it will be more advantageous, आपका performance और improve हो जाएगा. So the advantage of this microgrid structure ensures greater stability and controllability of for the power parks, right? So this is a new term known as power park, means it is combination of many microgrid. Environmental aspects आपने discuss कर लिया. Microgrid encourages the use of renewable energy sources. Large land impacts are avoided, and CO2 emissions are reduced, right? मतलब भाई अब लार्ज पावर प्लांट कई मेगावाट वाला, तो उसके लिए लार्ज स्पेस इज आल्सो रिक्वायर्ड. सो इन माइक्रोग्रिड स्मॉलर स्पेस इज रिक्वायर्ड. You can install smaller microgrids as compared to large generating station. So that can also help in some way to the overall power system. Conventional grid versus microgrid, that's also we have discussed already. Efficiency of conventional grid is very low as compared to microgrid. Same was discussed in the smart grid also. Large amount of energy in the form of heat is wasted in the conventional grid, right? Because in the transmission. So we have discussed all these points in different way. Power source in case of microgrid, often referred to as micro source, are small and are located close proximity to load, right? So that is not there in the conventional grid. So advantages of microgrid also I think may be similar. The major advantage of microgrid is its ability during the utility grid disturbance to separate and isolate itself from the utilities seamlessly with the little or no disruption of the load within the microgrid, right? So this we have seen. So if we can disconnect to the grid and we have sufficient power, that power can be supplied to the load without any disturbance or without any problem. So in peak load period, it prevents utility grid failure by reducing the load on the grid, right? जब peak load होगा, otherwise in the absence of the microgrid, the whole load will be supplied by the main utility or the grid. But if it is having microgrid, the local load will be reduced as seen by the utility. Significant environmental benefits may made possible by the use of low or zero emission generators, right? So our generators, if it is PV or wind, emission is zero, or if it is some smaller unit like DG generator or some other type of generator, so there may be some low emission. depending on the type of DG you are using. The use of both electricity and heat permitted by the close proximity of generator, that is CHP we have discussed. So heat can be saved. Extra heat generated can also be stored. So energy can be stored in the form of heat also. That is the concept of CHP is used in microgrid. Microgrid can act to mitigate the electricity cost to its user by generating some of or all of its electricity need, right? So otherwise आपका जो electricity bill बहुत ज़्यादा आ रहा है, आपने solar plant install कर लिया, one time investment is there, so when आपका जो है that cost is overcome, so then only profit is there, right? So your bill will be either reduced or it will be all zero after some years. So that cost is overcome, then only profit will be there. Some disadvantages are also there. Voltage frequency and power quality are the three main parameters that must be considered and controlled to acceptable standard, while the for energy balance is maintained, right? While so whenever means we are having solar power plant which is generating DC, when you convert it to the AC, it may be having harmonics, some voltage problem may be there. So controller should be good enough to meet all the standard within the acceptable limit, right? So that controller should be properly designed so that these problems should not be there. Voltage frequency and power quality problems should not be there, which is normally there in case of microgrid. So if your controller is good, these problems may be avoided. So electrical energy needs to be stored in battery banks, thus required more space and maintenance, right? So if you have battery की भी अपनी limited life है. So now good batteries are coming and research is going on in the area of storage also. So day by day improvement is there, but some maintenance is required. So you might have used battery in your inverter, might be using in your car also. So you know that the proper maintenance of the battery is also required. So same is in case of microgrid also. If you are having some storage system like battery, so resynchronization with the utility grid is difficult. So whenever this fault is there, when you are again connecting it to the grid, so it is not that easy to connect it just by switching on. So proper synchronization is also there, right? Frequency matching and everything should be there. So that is the job of the controller actually. So it will first match the frequency, then connect it to the main grid. So it will be synchronized with the main grid. So that synchronization is a difficult task in that case. So the controller has to take care of it also. Microgrid protection is one of the most important challenge facing implementation of the microgrid. As we have already discussed, the protection system becomes more complicated when the two-way power is there. So right now the conventional distribution system is designed for one-way power only. All protection system is based on that. Because why it is there, it is operating in radial. So why it was done in radial? Because protection cost of protection system will increase when you connect it in the mesh. In case of mesh system in the distribution system, the power will be two-way. Again, in the absence of the microgrid also, if it is in the loop, so power can flow in either direction. So the protections, it can be done. It could have been done, but the cost of that protection system will be very high and it will be more complicated. Now, same thing is now coming when we are connecting the microgrid. So earlier, the cost was a major issue. Now the cost is not the major issue. Government is having enough money, right? So they may do it. So we can bear that cost of the protection system over the other advantages, but you have to take care. You have to change the protection system again for two-way power flow actually. Issues such as the standard charges and net metering may pose obstacles for microgrid, right? So the power is flowing the both way. आपने अपना खुद का, you have your own PV generation, your own solar generation, right? So you would like to earn money also. So net metering system is to be installed. So that may be an issue when you are purchasing power, when you are selling the power, both ways the power is flowing. Again, the two-way flow for metering also. So that is also a difficult task. Interconnection standard needs to be developed to ensure consistency according to IEEE. Standard proposed by the Institute of Electricity and may end up filling the void. So हर एक का एक standard जो है IEEE has given some standards. You have to follow those standards. Otherwise, there would be different user might be using different standards, so that consistency may not be there. So whenever there is a problem of consistency, IEEE's role comes into the picture. They give some standards, so everybody has to follow those standards. So some standard is to be defined for these microgrid also. Now coming to the demand response, if we have time. Yeah, we have time. So many times I was discussing about the demand response, demand response. So this is the control of the load. Earlier, what is the thing that whatever load is there, that will be there. Utility has to supply that load. So it was not the in the reverse direction, that you can change the load also depending on the utility, right? Suppose the utility, the generation is less, demand is more, they will cut the load, right? But if it is in the hand of the user and they are participating in the demand response, they can divert their load and they can help in reducing this problem. So there will not be a power cut. You are switching off some of the unwanted load, only critical loads are on. So you can help utility during the peak hours, and you can shift some load from peak hours to light peak hours to reduce the peak demand. So that will help the utility a lot. So according to the Federal Energy Regulation, the definition is changes in electrical uses by the end user customer from their normal consumption pattern to in response to change in the price of the electricity over time, or to incentive payments designed to induce lower electricity use at a time of high wholesale market price, or even or when system reliability is in the geoparadise, means it is in the danger. That means what? There are two things. One is the utility will change its tariff. They will say that during this, whenever the peak hour is there, when they are not able to supply the power, they will raise the price of the electricity. Suppose normal price is 4 rupees, they will say during this particular hour, the price of electricity will be 10 rupees. So naturally, you would not like to pay more bill. So when you know during this hour, the electricity price is 10 rupees, in other hour, the electricity price is 4 rupees. So you will like to do some work during that hour. You can avoid. Suppose आपको washing machine चलानी है, और nowadays programmable washing machines are coming. You can set the time. During that time, it will operate when price is low. So when even if you are sleeping, also automatic washing machines are there. They will operate during that hour. But if you run that washing machine in the peak hour, when energy price is more, your bill will be more. If you are running that washing machine during the hour when price is 4 rupees, your bill will be less. So if you know that price is very high during this hour, you would not like to run some of the load like dishwasher. You can shift your ironing करनी है या कोई battery charging करनी है. So in future means after 5 years you will see everybody will be having their own. Now आपके everybody is having इन्वर्टर तो होगा सबके घर में, बैटरी उसका भी है, वो चार्ज हो रहा है अभी तो. whenever it is charging, it is automatically. When power cut is not there, battery is charging. But if you put some controller in between, some power electronic device, so and it can be programmed, it is connected to the computer also. So very soon it is going to happen. So computer is controlling depending on the price. The battery charging, discharging is automatically being controlled, right? So some power electronic device is connected between the power supply and the battery. So when you have to charge a battery, when you discharge a battery, so charging a battery can be shifted during the you know, low price hour when price of electricity is less. So this is based on the price only. So what is the one concept? यहाँ और लिखा ना, so before or means price of the electricity. That means only the utility is changing the price only depending on that some of the load will automatically will be shifted from the peak load to the light load hours. This is one thing. Second idea may be that they can provide some incentives. No, they are here, they are not giving any incentive. You have to manage your electricity own depending on the price of the electricity only. Now here incentive is also there. But if they say if you help utility when they want, you cut your load when utility wants, then you can use the load. So if you are doing in their favor, they will give you some incentives also based on that. Here only you can save your bill and you have to manage your own, but utility is not paying anything to you. But here utility is paying extra for disconnecting your load during critical condition. So you are helping the utility during the peak hours. Other way also. Or in the same way, penalty may be there. If you are not doing, some penalty may be over the bill. You have to give some additional price also. So that may also be there, right? So these are the things. So this means load is also controlled. Otherwise, earlier load is not controlled. User can switch on their load anytime they want, and utility has to supply the power to that load. So during one particular time, load will be very high. Now see, this is what is the flattening of the load can be explained by this diagram. Now see, this is a peak demand here. So this is when suppose demand response is not there. So only for very small time the peak load is there. This is for maybe 1 hour, in a day. But to supply this load, the capacity is to be there. Generating plant has to install additional means they have to arrange everything for this small period actually. So extra generating unit may be there, extra power is to be supplied. For that, extra fuel is to be burned. Cost of generating utility will be very high to supply this load, which is of very small duration. So normally the peak load is of very small duration. The peak load demand occurs for a very short duration of the period, but requires expensive peak load generation. The cost of that extra energy is very high. To generate that power, you have to burn more fuel. You have to install additional generating units. You have to turn on that, right? So everything is more. So to generate that power, a lot of inputs to be given. So that everything is in terms of money only. Cost of generation of power during that hour is very high. So the price of electricity should also be very high. और अभी इंडिया में तो क्या है कि फ्री पावर देना है, पॉलिटिक्स इज देयर, पुअर पीपल आर देयर, दे हैव टू means है ना, you provide connection free of cost for agricultural user for poor people. You said we are giving a single point connection. आपने सोचा एक बल्ब जलाने के लिए दिया, लेकिन वो तो उसमें सब कुछ चलाएगा. When power is given to them, he can connect any device he wants. But your intention was that only one he can switch on one light. At least he will not be in the dark, but he will be using it for some other loads also. That is all there. That's all these things are controversial. Politics is there, but in India it is happening, right? So, but generating cost is becoming more, so that is to be paid by other users. So, you know, and we cannot increase the price more also because so what utilities they are having a flat rate or some tariff maybe they are it is beyond certain your unit is beyond certain points, so then the cost of electricity will be more, but mostly it is not there in our system actually, right? But it is coming in future, it will be coming. So but at the same time DGs are also coming. So when DG supply this load, this peak will be reduced automatically. So it is just like that. The cost of generation during peak hour is more, which results in further economical drain to the utility. The peak load generation are mostly viable to environmental causing pollution threats also. So generally यहाँ पे आपका ज़्यादा fuel burn करेंगे तो pollution भी ज़्यादा होगा, right? So all these things are there. So if you force the user to shift the load during this, अब इसकी प्राइस नहीं ज़्यादा हाई कर देंगे, यूजर ऑटोमेटिकली ये लोड यहाँ से हटा के कहीं यहाँ करेगा, यहाँ लोड, यहाँ प्राइस बहुत कम होगा. So this load can be shifted from this peak to this valley. So है ना, आपका ये लोड कर्व थोड़ा सा और फ्लैट हो जाएगा. यहाँ इसमें देखो peaks and valleys are very high and very low. Here it is not that low. It is more flattening of the curve. This is known as flattening of the curve, right? So this is what demand response is there. Step 1, energy users sign up voluntarily, reduce energy uses in times of extreme demand. तो यूजुअली आपके साथ एक कॉन्ट्रैक्ट साइन करेगा कि जब आपका डिमांड बहुत ज़्यादा हाई होगी उस समय आप अपना एनर्जी यूजेस कम करोगे. So you are promising that. So if you are helping them in doing that, you will be given incentives also. Or the price of electricity will be less, so you will automatically do that. Both the things are there. Different strategies are there. In different paper in the literature, you will see different strategies there. This is a common strategy which we can discuss. The electricity demand surges, for example, due to extreme weather. राइट. अब आपका एकदम से सन बहुत ज़्यादा, गर्मी बहुत ज़्यादा, एकदम से एसी ऑन होंगे. तो इलेक्ट्रिसिटी यूज इज डायरेक्टली कनेक्टेड टू द वेदर ऑल्सो. व्हेन है ना, heat is more, you will switch on the AC, so demand will increase automatically. When in the winter you will not switch on the AC, during that period demand will be less in the, right. So like this, it depends on the weather. When rain is there, automatically the electricity demand reduces, because agriculture use will also reduce. So many load is very much sensitive to the weather actually. So depending on the weather is one of the component which decides load demand also. So this is just example shown. Due to some reason, if load is increasing, the user reduces their energy consumption. यहाँ पर user ने भी उसका response किया, उन्होंने contract sign किया था कि जब when load will be high, I will be cutting some of the load. So during that time, he is not using some unwanted load, so that demand will automatically will reduce. Only critical loads are on. So that can be done automatically also, because price of electricity will be high during that time. Or if you are getting extra incentives, so you will be earning some money over than the saving the energy also. So reduced demand helps balancing the supply and demand and stabilize the grid. So आपका वो balancing हो जाएगी, and users are paid for their reduced demand. So same thing. So what we have discussed is shown in the form of diagram actually, is more understandable. Now see here, same thing. This is peak demand. If we can shift this peak, some load in during these valleys, so that can be done. So यहाँ पे आप बैटरी चार्ज कर सकते हैं, washing machine run कर सकते हैं. So some of the load which can be shifted, you will shift it to the valley period, and during this time the price of electricity will be less also. And so here you will be switching off some of the loads. So this peak demand is reduced, right? So reducing peak demand means आपको जो extra requirement थी वो भी नहीं होगी. हो सकता है आपको एक नया power plant install करने की जरूरत पड़ रही थी. That will not be there. So your microgrid is also helping in the same way. आपका ये peak demand area, हाँ microgrid होता वो supply करता तो भी peak कम हो जाता. So everything is that. So if you are having microgrid, you don't have to cut any load. You living your own lifestyle without any change. But if microgrid is not there, demand response is there. You have to cut some load. So as we have discussed in the previous slide, lifestyle will not change and peak demand will be reduced if you are having microgrid. So that energy can be supplied from microgrid also in this time. So utility load will be reduced. So you can think in both ways. So demand response along with microgrid, everything. No, after 5 years, you will see electric vehicles in every home will be there. Right? Everybody would like to purchase electric vehicles. So your petrol wali problem khatam ho jayegi, jo, it is a big political issue. petrol prices are rising. So that is a main mudda for the various political parties, right? So that petrol demand will reduce, will be, after when electric vehicles will be there on the roads. So in other countries, it is in use now nowadays. In India, it is coming. So after 5 years, you will see a lot of electric vehicles on the roads. So वो भी same है. Whatever is the job of the battery, but that is not permanently connected. When vehicles are on the road, they are using that battery when they are at the parking, so that can be connected for charging. So when during charging, you can take the energy from the battery also. You can, so that battery can work as a load also and as a source also. So some power electronic device will be there in between that charging station. So if required, suppose आपने ऑफिस जाके गाड़ी पार्क की है, कॉन्ट्रैक्ट साइन किया है, so utility can take the power from your battery depending on their requirement, right? जब आप घर आ गए रात को, फिर कनेक्ट कर दिया आपने, again battery is connected, so you have signed some contract, so the power can be given to the battery and can be taken off from the battery also depending on the requirement, and accordingly you will be paid. When utility is taking power from your battery, you are earning some money at the same time also, and during that time the price will be very high, because when utility is taking energy, that means ki it is, the load demand is very high and price is very high during that time. So all that thing will be defined and it will be done automatically. So in terms of money also you will be having some advantage. So only thing you have to take care that minimum charging should be left in the battery so that you can start your car and go to your office minimum distance. And during that time also again it is charging when your vehicle is running. Right, so minimum charging will be left. So that is also defined. When charging is less than that, automatically it will not take energy from your battery. And when your charging is right, more than certain limit, it will start taking energy, depending on the requirement. So I'm giving some introduction of electric vehicles also because time is less. I have slide for that also, but I think time will not permit. So in between only I am discussing that also. Okay. So now advantage of the demand response, so you can think of energy efficiency, economic efficiency is yes. In terms of money also there is advantage as I told you. Uh, Lower wholesale market price due to demand responsibility to displace the most expensive peak generation resources, avoid most costly new capacity construction by flattening the demand curve, right? That means कि आपने यदि load demand वैसे कम कर दी तो जो नया generation install होना था that will not be there, right? So you are avoiding that. To increase the capacity of generation, you have omitted that requirement. It also helps to consumers to earn incentives or feeder reduce electricity bill, right? Your bill will be also reduced, and if you are helping, you may get some incentives also depending on the scheme provided by your utility, right? Some economical benefits are there that we have already discussed. Here it is written in the words only. Same thing we have discussed already. System stability definitely when load increases, so suddenly the peak active power demand increases, so that the speed of the generating station generator, synchronous generator will reduce. So you have to increase the speed steam input. So that is the automatic control. But that frequency, suppose load is suddenly increased and that is steam input is not able to control that much change, there will be a problem of synchronization with other synchronous generators. So the generator may go out and there will be a problem in the system and it may have cascade effect and it can convert it into the complete blackout also. So that reliability or stability problem will not be there. So when synchronous generators are going out of synchronous, that is stability problem. And when it is gone out, means shut down ho gaya, so then some of the load is to be cut. So that is a reliability problem. So to maintain the reliability of the electrical system in the event of an emergency and avoid brownouts or blackout. Brownout means some power is cut. Blackout means complete cut, shut down. Demand resources can be used to provide ancillary services, right? So you can additional services are there. Ancillary services are means main service of the utility is to maintain the power supply actually. Other than that, some support services are also there, right? So that services can be you know run by this additional power actually, right? So such reserves are balancing by quickly increasing or decreasing the demand, right? So demand response will help in all this. Environmental benefit we have discussed, right? So same thing, you are saving some carbon emission, fossil fuels because that load is not coming to the utility. They don't have to generate that much electricity. To generate more electricity, more steam is required. To generate more steam, more fuel is required. So more fuel will be burning actually. So if you are reducing that demand, less electricity is to be generated, less fuel will burn, right? So this is in the absence of microgrid actually. If a microgrid is there, that will supply that additional power. So in demand response may be there, right? It is maybe a combination of demand response means you are changing your load schedule depending on the price of the electricity or depending on the incentives or penalty. You are changing your normal routine, right? अभी तो आप ध्यान देते नहीं हो लाइट जल रही है जलने दो कोई बात नहीं. But when it is there, you will switch off some of the unwanted equipments. So that is demand response. So there are different strategies. They are in the literature. Price based demand response, as I told you, and incentive based demand response. Right? We have discussed already. So you can change the price of electricity depending on the load profile. When load demand is more, electricity price will be more. So it will be discouraged to use electricity during that hour. So automatically they will cut some load. So right, utility will see less load demand during that time. So that peak shaving will be there, and that load is shifted towards the bellies because the price of electricity will be less during those hours. They are encouraging to use your electricity during that time when price is less. So price is less when demand is less. When during that time the load curve is showing some valid incentive based may additional incentives or penalty maybe, right? So if you are helping utility to shift your load, so they are tempting you, attracting you to shift your load additionally by giving some additional incentives over the your bill price is reduced. Some details of that other than means within this PBDR means price based. There are so many techniques. In different paper you will find different small differences there. So all these are means real time pricing, time of use, a critical peak pricing, inclining blocking rate. So all these are price based with slight differences there in different papers. These different techniques are suggested. So all these are price based demand response. These are incentive based demand response. So in different paper you will find different strategies with slight difference, but all are these incentive based or the price based basically. Two types. You can divide them in two categories. The key requirement for implementing demand response, advanced metering infrastructure and technique to proceed the data generated, right? The advanced metering infrastructure should be there. It should be able to measure how much energy you are in the two-way metering actually should be there, right? So then only you will get proper advantage of it. Integration of distributed renewable energy resources and electric vehicles, right? So this is also part of demand response. As I told you, means if you have your own PV, so in future all this thing will be done as a combination. We'll see some graph also, some case study type is also in the forthcoming slides. So if you have your own PV generation, your own wind generation or battery storage are there or electric vehicles are there. So they are helping in demand response in other way, as I already discussed. Right. So during peak hours, when electricity price is more, you will disconnect the grid and you will use your own power. Or if you are not disconnecting also, so additional power only you are purchasing from the grid. Remaining power you are generating your own. So only additional power will come from the grid. When excess power is there, you are supplying that power to the grid. So all that thing is also there. So that is also part of demand response. So you are helping to reduce the load as seen by the utility. If it is locally supplied, that will not be seen to the utility. Utility has they don't have to supply that load because it is locally met. So the load demand from their side is reduced actually. So government regulations for increasing the adoption of demand response programs. So this is also key requirement. So government also has to change their rules. They should change the regulations such that they are encouraged to adopt this demand response program, right? तो आप यूजर को encourage करेंगे तो ही वो है ना तो आप इंसेंटिव देंगे ये आपको रूल में लेके आना पड़ेगा कि your incentives will be given or if you are not following penalty will be there so both the things may be there. इंटीग्रेशन ऑफ डिस्ट्रीब्यूटेड एनर्जी रिसोर्सेज एंड इलेक्ट्रिक व्हीकल्स ये मैंने बता दिया यदि ये लगाएंगे तो यू कैन अंडरस्टैंड नाउ आफ्टर सो मच ऑफ डिस्कशन ऑफ स्मार्ट ग्रिड एंड माइक्रोग्रिड so that will also help in demand response program actually. So let us come to the pictorial view case study type of thing. This is suppose load again the same thing means peak is shifting towards the valley. So during this time you can energy storage भी कर सकते हैं. Demand response program is there, so you will shift some load from this part to this part actually. Same thing is shown in this diagram. Now this is a single house is there. Suppose we are taking an example. House energy management system is there. That is computer program you are having. Smart meter is there and that is connected to your utility grid से connected है. तो ये दोनों वे आप कितनी एनर्जी ले रहे हो कितनी दे रहे हो इट इज रिकॉर्डिंग दैट सो दिस इज योर हाउस इन योर हाउस यू आर हैविंग PV also and electric vehicle is also there storage is also there right so everything is there and some of the appliances which can be shifted to some other time like dishwasher or washing machine or something water heater all these loads you can shift depending on the requirement. But something you cannot. The fridge will be on continuously. Your AC when you need only then only you will turn on the AC. So AC cannot be controlled. जब आप सो रहे हो गर्मी लग रही है उस समय आपको ऑफ करने को बोलेंगे then you will not switch off. और जब आप ऑफिस चले गए तब आप ऑन करो because price is less so that is not possible. Right. So only load which can be shifted then only that only are controlled and can be shifted. Like electric vehicle is there that is also connected. So the battery can be charged or discharged depending on our requirement, right? Your PV is there. यहाँ पे आपने solar cell भी install कर रखा है, तो आपका generation भी हो रहा है. So everything is there in your house. Suppose so, what is the case now? This is all day demand of the house. ये आपका load demand है आपके घर में कि सुबह 8 बजे से लेके शाम के 5 बजे तक आपका लोड कांस्टेंट है कोई फ्रिज कनेक्टेड है या कोई कनेक्टेड डिवाइस है वो चल रही है बस मिनिमम लोड इज देयर राइट आपको रात में भी घर आके 12 बजे के बाद सो गए हैं तो ये ऑलमोस्ट सारी चीजें ऑफ है तो ये कांस्टेंट लोड इज कमिंग so during this hour you are turning on and off some devices during this hour also you are turning on and off some devices so this is your load pattern of a single house suppose right now see this is the real time pricing provided by the utility ने कहा कि इलेक्ट्रिसिटी प्राइस ये होगा इस टाइम पे 2 रुपए समथिंग होगा इधर 3 रुपए समथिंग हो गया यहाँ पे पीक डिमांड लोड ज्यादा होता है तो यहाँ पे है ना 4.5 समथिंग लाइक दैट प्राइस इज मोर right so different hours the price of electricity is also different here the price of electricity is very less तो रात को जब सब सो गए हैं तो उस समय यदि आप कोई लोड शिफ्ट कर सकते बैटरी चार्जिंग इस समय करें या आपका वॉशिंग मशीन इस समय चलेगा तो आपका लोड यहाँ से यहाँ शिफ्ट हो जाएगा यहाँ तो प्राइस बहुत ज़्यादा है So you would like to shift your some of the load during from this hour to this hour, right? So यहाँ पे peak shaping हो जाएगी, यहाँ पे filling हो जाएगी. So your load profile will be more or less flat, right? So that is what is desired. So that can be done automatically because this price pattern may change daily. This is real time. So this price is coming to your computer. The website is providing that price. So computer is continuously reading that price. Accordingly, it is taking action. So all devices are connected and they are controlled and they can be switched on or off depending on the price. Now this is typical solar power available. यहाँ दिन में यहाँ पे ज़्यादा होना चाहिए था लेकिन इस समय मान लो बादल आ गए तो आपका यहाँ पे सोलर पावर मिलना था वो नहीं मिल रहा. सो दिस इज अ टिपिकल डे टाइम इन विच मीन्स यहाँ पे सुबह हुई सन आया सन करीब 9-10 बजे आपको पावर मिलना शुरू हो गया. यहाँ बहुत कम मिल रहा था, यहाँ ज़्यादा मिल रहा है. फिर जब मिलना चाहिए था उस समय बादल आ गए. सो दिस इज डिपेंडेंट ऑन द वेदर, इंटरमिटेंट है. So typical, if sun is available throughout the day, this will be of this pattern, right? So here some interruption is there, so you are not generating that much power which is expected. So this is the output of your solar system. PV आपने जो घर पे लगा रखा है, that is generating this much of power. So power generated by PV panel installed at your home. Now this is it. This is power consumption sold back to the grid, right? आप grid से कितना power ले रहे हैं या दे रहे हैं वो है. So when it is red है तो grid को sell कर रहे हैं, your power is sold, and when it is blue you are purchasing the power. So power is being taken from the grid when it is blue, when it is red it is being sold, right? So where it is being sold, when it is यहाँ वाला ये कट हो गया, आपका लोड इतना था, ये एक्स्ट्रा पावर है. So this is energy utilized by PV source system and EV. आपके खुद के लोड ने, your load is utilizing this much power from the solar. PV power used by your load, एक्स्ट्रा जो था यहाँ पे एक्स्ट्रा जितना था वो यहाँ पे आ गया रेड पार्ट में. So additional power which was generated is being sold here, right? तो यहाँ पे नहीं अवेलेबल था तो आपने फिर ग्रिड से लेना पड़ा. So this blue part again is in between, you have taken that power from the grid, and this red is the additional power during this hour when solar power was available to you, you are selling. Now this red here is means blue means EV ने use किया ये power. Red means your battery is using this power, right? एक fixed battery भी है और EV भी है. So during this hour your है ना, बैटरी आपके रात को भी चार्ज हो रही है. Some battery charging is here, some battery charging is here in the morning when you are not going to the office, you are leaving the office after suppose this time 8:30 or 9 you are leaving. So this time EV is not connected, right? EV is being charged here, and this is battery is being charged here, right? So battery यहाँ charge हो रही है, यहाँ पे price कम होगा, like this. So it is shifted. This is the shift of shiftable load have to optimize the operating hours. So you are shifting that load. This is normal. This is load shifted, right? So battery charging is shifted here and here. Washing machine is shifted here. Dishwasher shifted here. During this time it is running. EV is charging here, right? So during this time the price was less, so you have shifted your load here actually. So this is the advantage. So you are selling some energy, some, right? So this is a typical example of demand response. So thank you so much. It is more than 12. Time is also more. So I will stop here. And
yes, sir. Thank you, sir. Dr. Anil, sir. Thank you very much.
Thank you. मैं वो मीट वाला पेज नहीं. Hello.
Yes, sir. Can I conclude the session in few words?
Sure. Yeah.
Oh, okay. Participants, today Sir has delivered the lecture on the topic microgrid introduction, implementation, and its control. Sir started with the definition of microcontrol, and he has shown the structure of microcontrol, what is hybrid microcontrol, and what is the need of microcontrol. That is, he has quoted various advantages like losses are reduced, quality and reliability of the energy system is improved, and to the critical loads, emission of CO2 is also reduced. That is, it gives the environmental benefits also. Sir has told us about the objectives of microgrid operation. And the objectives are many, that is to maximize the economic profit, to maximize the technical profit, to maximize the environmental profit. And there is a compromise among all the three. Then Sir has discussed about the comparison between the centralized and decentralized control, decentralized microgrid, and Sir has given us about the various control schemes of employed in microgrid like PQ control, drop control, master slave control, and many others. And well, Sir has given about knowledge about the interconnected microgrid, and he has introduced a new terminology, that is power parks, which is a combination of many small microgrids. And Sir has discussed about the environmental aspects, that is more use of renewable sources of energy, less emission of CO2, more efficiency, and also the site of microgrid is very close to the load. The major advantages is voltage, frequency, and power quality. These are the three major parameters which are controlled using this microgrid. But disadvantages are also there. The traction is the major challenge. Battery storage is also required, and resynchronization with the existing grid is also an issue. And in the second part, in the latter part, Sir has discussed with the demand response. There is a demand side management. If the consumer can manage the demand, and if he uses electricity during the off-peak period, then the load curve can easily be flattened. And Sir has quoted many examples of this programmable washing machine, dishwasher, which are the manageable loads at consumer end. And also, the consumer will be given the incentive if they follow this. If they can help in maintaining this load curve, and also the working of this demand response, how microgrid can help to manage the peak demand, which is happening, which is only for a few hours in a day. So, Sir has put in many informations about the microgrid. So, I am highly thankful to the Sir from my behalf and the behalf of my institute, Ganga Institute of Technology and Sciences. Anything left, Sir, from my side?
आपने सारा कंक्लूड कर दिया पूरे 1.5
I
घंटे का
tried,
लेक्चर
sir.
आपने 5 मिनट में so you were
None of
noting down
that.
everything. That is very good.
Sir,
So
I was trying to do.
it's very well concluded.
Doctor, may
Thank
I ask you, may I ask one question, sir?
Sure.
Doctor, even we are publishing number of research papers in these DR programs actually, and why our country is not doing actually why this sector, electrical sector, is not adopting the implementation of DR in India. Actually, I came to know from one some sort of case study from Mysore actually. They implemented one project on DR in Mysore actually. So, if there is initially there is a requirement to run.
No, this may I cannot answer this because so many political issues are there, so many things are there. So, but government is working on it. They have, as I shown you, you can visit the site of MNRE, which is working on this. So many means organization has been made just for the smart grid, and so maybe the progress is slow, but in future you will see it very soon. Now, see, change will come automatically. Nobody can stop it, right?
Even
The
I have gone through
obstacles may be there.
number of government
Obstacles may be
policies.
there, but because in India, you know it very well, ki the changes do not come out very fast way, but slowly the change will be there. So if you see over a long duration time, means changes are being done. जैसे अभी you see roads are quite improved and right a lot of transportation system is quite improved. Means over bridges installed, right? Metros are being installed, and so smart city concept is also coming. Although the work is slow, but some delta X is there, so it is being added. So in Mysore, you are saying it has been installed, so it's good. But now you see, I don't know what is in situation in Jabalpur and in Jaipur. I see in many houses the solar panels are being installed. So it is not only government, the user can also do it. Suppose there is a small township having 100 or 50 flats, they can have their own microgrid. So we should not be dependent on the right. So because benefit is there for to you also. If you are installing solar power plant, you are having benefits. So you can have your own because this is a time when you can install because after some time the utility will put some limit means it cannot be more than 30% of the total load. So when maximum houses will be installing that, the limit will they will start putting the limit also because that will create a stability problem, right? So there is a limit also. So government is doing their job. I don't know what is actually what is the ground situation, but you can visit the website of mnre.gov.in, right? Ministry of New and Renewable Energy. So a lot of information is there. So according to that, the means we are following the what is planned as far as solar power is concerned, right? In means Rajasthan or in Gujarat, a lot of means large solar plants have been installed in the transmission system. So uh, the changes are slow, but it will be visible up to some time.
Okay, even
According to
there is a requirement to aware the customer about the implementation of DR or ADR program in India. Actually, even I have seen none of the awareness program is running by the government of this Ministry of Power or Ministry of Energy actually to aware the customers also.
the information is available naturally, and
At the
this awareness is to be
at the
done.
distribution utility of any state is not even exploring the any awareness program to the customer, even residentials, commercials, and also industrial customers also.
Yeah, it is not that propagated. That awareness is not as it is required actually. But information is there on the website. But in India, a lot of users are not using that also. So, I know just solar. Maybe your discount is there, some concession is there if you are using it right now. So all these information should be available to the user. You are right. So it is not up to that extent which it has to be. So
The large
what you are
terminology.
doing this faculty, what we are doing that thing now. You are running this faculty development program. So in that you are spreading the information to a lot of people. They will be spreading it to more people. But right from government side, what is to be done? I don't know what they are doing. Uh, I will not comment on that because I don't know the ground situation, what how much they have done and what they are doing. A lot of NGOs are also working in villages. They are trying to install solar power plant in remote area. So those who are willing, they can do actually.
Even that by seeing the terminology, the demand response, the response term is already very much clear that the customer will respond actually. When the government will not aware the customers, then it can be, it is not possible to implement actually.
It is
And
not forcefully. There are so many schemes. In some scheme, it is forced. They will be directly cutting your load. I mean, some of
yes,
the loads are controllable and they are in the control of the utility. So
yes,
you will sign some contract. So whether you want to participate or not, it is your choice. So when you have signed the contract, I shall be participating, and utility is cutting your load. So you will be given incentives for that.
even
So
sir, in case of enrolled customers or say registered customers, if they are not participating, then they will get some penalty also, sir. In the case of DR,
that depends on what regulation says, what government
okay,
the regulation they are making. So whatever scheme is to be made by the government, Accordingly, it will be, it is not automatic.
Okay.
So if they are not participating, but depending on that, means suppose a tariff is there. If your electricity consumption is 100 unit only, so tariff rate means your electricity price will be 4 rupees. If it is going beyond 100 unit, so the electricity price may be 10 rupees. So you will try to limit your load within 100. If you are not doing so, that means you are having enough money, you can pay that bill, no problem. So that way we cannot force the consumer. But if some consumer wants to participate, they are willing. They have given their control of their equipment to the utility. They can directly cut that. So it depends. Ki what type of scheme government is proposing. These are different models actually suggested in different literature. So which model our government is adopting, or utilities are adopting, that depends.
Even there is a also requirement, some requirement of augmentation of their infrastructure also, like AMI, etc. Without AMI, we cannot implement this VR programs.
What is
Okay.
AMI?
Yeah, this is advanced metering infrastructure actually.
Hmm.
Okay.
So
Thank you.
these things are in.
Thank you. Yes.
Abhi, slowly they are coming, but they will come. After 5 years, you will see some major change.
Thank you. Thank you for
Okay, okay.
Shalini ma'am. Now we can conclude this session actually with your
Yes,
permission.
sir. Yes, sir. Yes, sir. Yes, sir. Dr. Anil, sir, again, I'm thankful to you for giving your precious time for us. Thank you very much, sir.
Thank you so much for inviting and giving me this opportunity.
Sir, it's our
So
pleasure.
it is my pleasure also. Whenever you require, and if I am available, I will be joining you.
Sure, sir. Sure.
Thank you. Thank you
Thank
so
you.
much. Okay.